Partial depth repairs are effective in correcting distresses confined to the upper one-third of concrete slabs. This technique has been used successfully to repair spalls both at joints and at mid-slab sections. Proper partial depth repairs can restore distressed pavement, enhance rideability, and remove hazards caused by spalls. In recent years, new materials and mixes have been developed which, if properly applied, allow for early opening to traffic, often in less than 8 hours. To provide a good understanding of partial depth repairs, this program will focus first on the materials used and then on the entire repair process. Typically, a conventional concrete mix is used if the area will be closed to traffic for 24 hours or more. For rapid partial depth repair, materials capable of obtaining high strength soon after placement are used. These include high early strength PCC mixes, rapid strength proprietary materials, and polymers. High early strength concrete for rapid repairs contains either type 1 cement with admixtures or type 3 cement with or without admixtures. Both can attain compressive strengths in excess of 3,000 psi in 24 hours. A number of proprietary materials may also be used. For best results, it's important that the manufacturer's guidelines be followed closely. Still, other materials such as epoxy mortar and epoxy concrete can be used to make the repair. Again, the manufacturer's guidelines should be followed closely to obtain the best results. The selection of the type of material to use should be based on the lane closure time, climatic conditions, desired service life, cost, and local experience with the material. Okay, now let's look at the procedure for making partial depth repairs. There are 4 basic steps: determination of the repair boundaries, surface preparation, placement and consolidation, and finishing and curing. We'll start, naturally, with determination of the boundaries. The preliminary boundaries should be established before work begins. They can be estimated from the results of a preliminary field survey. It is also advisable to obtain representative cores from the distressed areas to determine the depth of the distress. Because pavement deterioration is progressive, however, the exact boundaries are not established until the time of the repair. In many cases, the extent of deterioration will not be visible. Delaminations may lie just below the pavement surface. So the exact boundaries are determined by sounding the pavement with a steel rod or a lightweight hammer, or by dragging a steel chain across the surface. A clear, sharp metallic sound indicates good concrete. A hollow, dull sound indicates deteriorated concrete, areas of the pavement that need to be repaired. Once the exact repair boundaries are established, they should be clearly marked. Normally, the marked area should extend 4 inches beyond the distress to ensure that all deteriorated concrete will be removed. If the marked area will extend within 1 foot of the shoulder, the repair should be extended to the shoulder. Similarly, if 2 repairs will be within 2 feet of each other, they should be marked as 1 repair. In all cases, the repair should be marked in a square or rectangular shape. That brings us to surface preparation. The deteriorated concrete can now be removed by sawing and chipping, cold milling, or water blasting. Regardless of which method is used, it's important that all unsound concrete be removed. The depth of removal, however, should not extend below the top third of the pavement. Deterioration extending any further may indicate the need for full depth repair. When the saw cutting and chipping method is used, the first step is to make a vertical saw cut about 1 to 2 inches deep along each mark. For large repairs, additional saw cuts may be made within the perimeter to speed up the chipping process. Chipping should start at the center and progress toward the boundaries. Periodically, the bottom of the repair should be sounded to ensure that all deteriorated concrete is removed. As for the chipping hammers, it's important that the proper size be used to avoid damaging any of the sound pavement around the repair area. Hammers weighing up to 30 pounds are acceptable for removing concrete in the center of the area. But for chipping near the edges, hammers should weigh no more than 15 pounds. Extreme care is required to avoid damaging the concrete along the vertical faces and to avoid fracturing or undercutting the pavement surrounding the repair. Cold milling is especially effective for repairs extending across a major portion of the pavement, such as in full lane width repairs. Carbide-tipped milling machines and diamond blade grinding machines work particularly well because they can be preset to remove material to a specified depth. Although these machines produce non-vertical faces on 2 sides of the repair, they usually don't cause edge spalling commonly associated with feather edging. The third option is water blasting. Here, water pressures of up to 30,000 psi are used to remove the deteriorated concrete. This method has 2 advantages. First, all the material can be removed without the danger of damaging the surrounding concrete. And second, water blasting leaves a clean-cut surface with excellent roughness and angularity, which will promote bonding with the repair material. There is, however, one disadvantage. Because of the tremendous water pressure, it's difficult to control the depth of removal. But regardless of the method used to remove deteriorated concrete, the repair areas must then be thoroughly cleaned of all residue. This is best accomplished by sandblasting and air blasting. Sandblasting cleans the surface of dirt, oil, and other residue. It's also capable of removing the last particles of unsound concrete. Air blasting removes any remaining residue. It's important that the compressed air be free of oil, because oil sprayed onto the surface will hinder bonding. After cleaning, you should be able to rub the surface without picking up any dust or other contaminants. And those are the surface preparation requirements when the repair is made in the middle of the slab, away from joints and cracks. At joints, however, there's an additional requirement. The existing sealing material must be removed to prevent its contaminating the repair material. At both joints and cracks, a compressible insert is required. Its purpose is to prevent the repair concrete from intruding into the crack or joint. Now that's important because the forces created by expansion or differential movement of the adjacent slabs have to be reduced or eliminated. At transverse joints and cracks, the insert has to extend an inch below the bottom of the repair area, and laterally 3 inches beyond the end of the repair area. Sawing may be necessary to obtain these dimensions. Polyethylene, styrofoam, and asphalt-impregnated fiberboard are all acceptable inserts. These same materials may be used at longitudinal joints and cracks. When extra side support is desired, stiff polyethylene strips or a thin piece of plywood may be used. Bonding may or may not be required as the last step in surface preparation. It is required when PCC and some of the proprietary materials are used. For these, epoxy has proven to be a successful bonding agent. Sand cement grouts are another type of bonding agent, but are not recommended for rapid setting materials. Bonding agents should be applied according to the manufacturer's recommendations by brushing or spraying. If epoxy is to be brushed on, it's best to use a stiff bristled brush. Spraying is more suited to large areas. In both cases, though, the material has to be applied completely and uniformly to the bottom and sides of the repair area just prior to placing the concrete. Now, placement and consolidation of the repair material. Because of the small amounts of concrete typically required, drum or paddle mixers are normally used to mix the concrete at the job site, especially when rapid set concrete is used. In any case, the material must be mixed according to the specified procedures. Once the material has been mixed, it should be shoveled into the repair area to avoid segregation. And it's best to overfill the repair so that it'll be completely full after consolidation. Vibrators less than 1 inch in diameter are typically used to consolidate the material. For proper and complete consolidation, the material should be vibrated by dipping the vibrator vertically into the material at locations throughout the repair area. When moving from one location to another, the vibrator should be lifted out of the material, not dragged through it. For very small repairs, adequate consolidation can be achieved by rodding and tamping and cutting with a trowel or other hand tools. After consolidation come finishing and curing. The proper procedure for finishing is to screed the material from the center toward the edges. This ensures good bonding at the sides of the repair. Hand troweling may be necessary to remove any minor irregularities. Any saw cuts extending into the surrounding pavement must be filled, either with excess mortar from the finishing or later with epoxy after the concrete has set and the cuts have been cleaned out. Although partial depth repairs are usually small and have no significant impact on friction, texturing is recommended to make the repair surface similar to that of the surrounding pavement. After finishing, it's strongly recommended that the edges of the repair be sealed. This can prevent delamination resulting from water seeping at the edges. A 1-to-1 cement water grout provides an excellent moisture seal. Because these small repair areas have a high surface area to volume ratio, they lose moisture rapidly. So proper curing is very important to prevent shrinkage and premature failure. For proprietary materials, the curing procedure specified by the manufacturer should be followed. Best results with PCC have been obtained by applying curing compounds soon after the bleed water has evaporated. White pigmented curing compounds that reduce heat absorption while allowing the heat of hydration to escape are very useful in hot weather. Sealed curing with moist burlap and polyethylene sheeting can also be used. However, shrinkage cracking can result because of the rapid moisture loss when the seal is removed. The use of insulated blankets during cold weather can promote rapid curing and allow early opening to traffic. After the concrete has gained sufficient strength, the joints adjacent to the repairs must be resealed. Normal joint sealing procedures and materials should be used. The repaired pavement can be opened to traffic immediately after the concrete has gained sufficient strength and the joints have been resealed. When the appropriate construction practices are followed, partial depth repairs can be a very cost-effective way of repairing pavements for early opening to traffic.